Right. A rocket enthusiast fires his model rocket vertically upwards. You can do something vertically downwards as well. But they must say vertically upwards from rest. The moment I say rest, you know it's 0 meters per second. Okay? And rest also is u, which is the beginning acceleration, with a constant acceleration of 30 meters per second. The fuel lasts for 3 seconds, during which the acceleration is constant. Ignore the friction. In other words, this fuel is up by 3 seconds. Now, how high does the rocket travel in 3 seconds? Now, first what you do is you write down what you've got. You've got A, which is acceleration at 30 meters per second, right? Squared, and then you've got the time at 3 seconds. Now, what you do is you need this particular distance. You need for distance, if you ask you for distance, you must pick that formula. Now in our days you had to memorize this formula. Now you get a formula sheet. You must just pick from here. Pick that one because you need to do it. That's the beginning acceleration plus the time, a half of acceleration, and t squared. Okay, so you fill in or substitute. That will be naught. Half of that multiplies 9 times that, 270. Half of that's 135 meters. This is 135 meters long. Much quicker than maths. In terms of maths, is much more difficult than physics. Because you've got a formula, just stick in what you've got and to get what you want. That is an example of just getting your distance. Here, another one, another type of sum. Tom has a mass of 100 kilograms and Pete has a mass of 80 kilograms. At the moment, Tom is moving forward with a velocity of 2 meters per second. And Pete tackles Tom in the opposite direction at 7 meters per second. He's running at 7 meters per second. The other one is running at 2 meters per second. Now they ask you calculate Tom's momentum. So the momentum now is the mass times the velocity. So P is equal to mu. And so you multiply the mass of the person with this velocity, and it's kilogram meters per second. That is the momentum of this person at which he's running. Now they say calculate the velocity of both players immediately after the impact. Right? Now you need this formula. P is equal to m plus m, m1, m2, which is the first mass and the second mass, times v. Now you want to work out v. V is equal to what's on the other side divided by what was next to. I always have that kind of x is equal to what's on the other side divided by what was next to x. Okay, if it's a multiplication there. So v is equal to what's on the other side divided by what was next to x, and that will be 1 and 2. If you split this up, then P will be the Tom's momentum plus Pete's momentum divided by their masses. Okay, so now go up, you go to this part here. So the total momentum would be, we worked out that one already as 200, the momentum of this one. But we haven't worked out the momentum of the other one. So it's his mass times his velocity, but his velocity is minus. Why minus? Because he's running in the opposite direction. Okay, so his amount will be minus 570. Subtract the 2, you get 360. And if you add the two masses, you get 180 kilograms. Now what's this? This is kilograms meters per second. And that one is kilograms. Now the kilograms will cancel out, you're left with meters per second. And that is basically the velocity after impact or at impact. Both of them are moving at 2 meters per second after they contact. Okay?